So, is everybody excited to look at context managers? I think context managers are another really cool feature. They don't have the same theoretical gravitas that decorators or generators might have. In fact, they're a very practical feature without the same, without maybe the same opportunities. Well, actually, no, you could really abuse them if you wanted to. OK, so I have something to do in my spare time now. But somebody asked to kind of give a reintroduction for what we're talking about. So pretty much we're having a very informal discussion about some very interesting, notable features of the Python language. Features that are notable, and also features that make the language notable. We talked, oh, is that it? Oh, it's at the top of the file. You can download the file here. You can download all 3 files there. I think the notes themselves are actually fairly useful. Control it. There you go. All 3 files. So let me get us to context managers, because I have some really neat context manager examples. Don't I? What would I be? Decimal. Precision. Oh, no, be a motivation. Yeah. There we go. OK, so is everyone ready, gearing to go? Did our flock return, more or less? OK, fantastic. So context managers. Does everyone know who knows what I'll start from not the beginning. Who knows what a context manager is? Who is totally clueless when I say context manager? Who thinks a context manager is like the guy who stands next to a politician and makes sure that everything he says is appreciated in the right context, even when it's like ethnic slurs and, you know. OK, fantastic. So a context manager, you can think that for the 3 features we've looked at, there is a substantial part of it that's just syntax. Decorators are just syntax for a type of functional programming. Generators are just syntax for a way to represent an object that can encode a delayed computation. Context managers are just one piece of syntax, the with statement, that allows you to wrap a block of code with a little bit of setup and a little bit of teardown. But before we go into the syntax, maybe we should just kind of explore why we might need setup and teardown code. So have you ever coded something, and there were a lot of very practical processing steps involved? And before each processing step, there was a necessary prologue. And after each processing step, there was a necessary epilogue. And you always had to do that first part, and you always had to do that last part. So can anyone think of an example of that? And somebody who has not spoken yet, unless those people are too shy, and then we'll fall back on the people who are chatty Cathys. So there's chatty Cathy and Gabby Gabby, right? Because Gabby's already, yeah, OK. No. OK. Oh, absolutely.
Make sure that you're connected
Remove all traces. There you go. There you go. We got a hacker in the audience right here.
I mean, you want to get disconnect. So
what does the name on your name tag say? Does it actually have your name, or is it like Neo? Oh, OK. But that's a really good example. Anyone can think of another example? Exactly. Oh, yeah, absolutely. Some sort of lock on something. I've seen that happen. You know, you say with lock, and then you deal with the lock, and you want to release it, right? And you can think database is a really good example. And a database has, I think, many layers of that example. So can you think of, like, there's a connection, but then there's a transaction, there's cursors, there's all sorts of layers where you want to make sure that you've wrapped your code very safely with something that happens before and something that happens after. Now you can think, what if, why wouldn't we just want to write this as our preamble code, then our processing code, then our epilogue code, just in the module, you know, function 1, function 2, function 3. Why wouldn't we just do that? And there's a reason for it. But you can probably think, if you spend a second or two, why we wouldn't. If we had a database, we could do db equals connect. This is fake syntax. It doesn't do anything. Why wouldn't we just do this? Why wouldn't we keep it simple? Very good. So if you can explain that too.
Yeah, you might have an exception occur on line 2, and then your query would not be called after it made the connection.
Exactly. Exactly. So that's where context managers come in. So does everyone have an appreciation for the why of context managers? So one other thing, can anyone think of any of the examples for what context managers use? I can think of one very common pattern for context managers. Reading a file is probably the most common place that anyone uses a context manager, with open file name as F, and then do your operations on it. Anyone think of any other very common uses of context managers, or very common pattern to context managers? Because I can think of one. Logging, I've seen them used for logging as well. You log something before and you log something after, right? But you can, and then it's a context manager, you could call it. And if this were Java, you could call it a context manager, factory, abstract, implementation, class. Very good. I think one other place for context managers where they can be used very nicely is for managing any sort of global state. Now you can think of the examples we've looked at are all some sort of management of state, but one other very common pattern that I've seen in production code of use of context managers is there's some global state and you want to control it. And in the standard library, there are some context managers provided for you that do that. I'll show you one example of that. I've skipped over the syntax, but I think you guys are brilliant, so you can pick up the syntax, no problem. Here. So there's a decimal library, and the decimal library allows you to do lets you do arbitrary precision arithmetic. And the precision with which you're doing this arithmetic, it can be set, and it's set on I think it's set on the thread basis, right? Now you can think that maybe you have some scientific code, and within some block of code, you need an enormous amount of precision. And you want to set your precision, you want to bump it up, run your processing code, which may involve accessing databases or accessing files or some such, or it may involve something that could throw an exception, and then you want to return the precision to what it used to be. You could write a context manager to up the precision. All the code within that context manager runs with that precision, and then return to the original precision. And in fact, there exists such a context manager in the decimal library called local context. So let's take a look at this example. So here I have two statements. What I've done is the local context manager provides you with an object, and that object represents the global context of your program. When you leave this block, you enter the block and you create a local context. When you leave the block, that local context is removed. It's like a layer. It's removed, and the previous settings are restored, which means in this block, all of my decimal arithmetic has a precision of only 2 decimal points. So you can see that suddenly 355 divided by 113, which should be a rough approximation for pi, is now between 3.0 and 3.2, and probably is it's 2 decimal points, so it should be 3.1. It should actually be strictly 3.1. You can see that I have strict equivalence. So within this block, my division now behaves differently. But the neat thing is, if I'm as forgetful as I really am, I don't have to worry about the original precision being reset. Outside of this block, everything continues as normal. And I believe local context is thread safe, so I don't have to worry about things going on crazy in other threads. Only within this discriminated context of this block itself do I have this local change in effect. And the moment I leave it, whether I leave it intentionally by hitting the end of execution, or by leaving it unintentionally via some exception being raised, or some signal being sent to the program, the original state will be, to the greatest degree that the interpreter can guarantee, restored. So this is, I think, maybe like a canonical example of how you can use context managers to handle global changes, or to very safely change things globally and be sure that they return to the previous state. Now, if you've ever done any hardware programming, I'm sure everybody who's done any hardware programming remembers, you save some set of bit flags, then you do some operations that may modify those bit flags, and you have to restore the bit flags, right? That's a perfect use case for a context manager. The context manager itself can save your bit flags or can save your previous state. Then within that block, you can do all your operations. And then when you leave that block, you don't have to explicitly say, restore my state. The act of leaving the block does it for you. I think that is really cool. Does anyone else think that could save them an enormous amount of time, an enormous amount of headache, and just keep them lying awake at night thinking about Python?
Make my C life a lot easier.
Yes, it would. And he's not a sailor. He actually means a C programming life. I'm a part-time sailor, so I actually have a C life. No, I don't. So let's take a look at some other examples of context managers. Here's one that I thought was actually kind of cool. So here's a simple financial example. It's a very artificial example, and you have a bunch of stocks, right? A bunch of tickers, and they have a price and a quantity, right? I'll show you. So it's just a ticker, a sector, a price, and a volume, right? So this represents a portfolio, somebody's book. And it looks like they really like information technology because they have a lot of Google and a lot of Adobe. But they have some Berkshire Hathaway, which is pretty good. Wow, when I wrote this, Google was trading at 579.8. It's pretty good. And what's Zom? I can't remember. I think that's ExxonMobil, yeah. Here's an interesting way to use a context manager. We can define a set of shifts to the market scenarios, and we can use a context manager to apply the shifts to our underlying data. And within that context manager, we can actually kind of structure this application of shifts without affecting the underlying data. Now, it's not really a necessary place to use a context manager, but it's an interesting way to kind of use this syntax. So the code ends up looking like this, right? This is saying, with a scenario called Facebook IPOs, and you can see in the Facebook IPO, I said that means that all infotech stocks are down by 75%, which actually probably more or less happened. And then under the second scenario, I'll say, OK, using the same portfolio, I'll adjust it so that I have some natural gas revolution. So all energy and infotech stocks are increased by 20% price. Figure out the market value. So this is not a necessary place to use a context manager, but you can see that it's an interesting way to structure this code. Would any of you actually structure your code like this in production? Is an open question that I'm asking you right now that people seem to think is a rhetorical question. I think that it might have its benefits. I think you could also argue that it has its drawbacks, but I think it's a very interesting way to look at the use of this code. So you can see that essentially the idea of a context manager is twofold. You have or threefold really. You have some preamble, some prologue. You have some necessary epilogue, something that happens at the end that'll always happen whether you leave by running to the natural end of your computation or by having an exception raised. You have some block scope variable, the P in the first case, that is provided within the scope of that block that represents some context necessary to that block. In this case, I'm not using the preamble and the epilogue part. I'm not using the prologue and the epilogue part. There's no setup and there's no teardown. All I'm using is this to wrap the existence of this block level variable. So I create a market scenario and I call it P, and I create another market, or I modify the portfolio and call it P, and I run another market scenario on the portfolio and call it P, and I find my market value on that. Now you could, please.
I'll say the difference between this and decorator. If you structure the decorator to set up and tear down after you run the function.
It's a very good question. What is the difference between the context manager and a decorator? And this is a very interesting, very deep question, because you can think. In places where you could have a context manager, you could easily write a decorator that takes a setup and a teardown step, and you could write that decorator so it wraps the function that tries the setup step, and if there's an exception, it leaves gracefully, then runs the function that was passed, and then it tries the teardown step, and if that has a problem, then it cleans up itself. And what you'd end up with is a single function that has this setup teardown built into it. And in some respects, this would be very similar to context manager. The one difference is, actually it's a very, that's a very good open question, I think, to ask everybody. For people out there who have used context managers, why might you use a context manager to explicitly handle the setup and the teardown, as opposed to, let me finish the question and then you can ask, or as opposed to using a decorator to bake that into each of the functions?
Sometimes you don't want the code that you're wrapping to be its own function.
Very good.
Recently I had a big long series of sequential steps
Mm-hmm.
that shared a lot of data.
Mm-hmm.
So I really wanted that all to be one function because it was all operating on the same data.
Mm-hmm.
But I wanted to wrap bits of data
Mm-hmm.
in order to print messages actually.
Mm-hmm.
So when I wrote a little context message or a context menu where when it enters the context message,
Mm-hmm.
you're now doing this, and then when we got to the end, and then the exceptions would say,
Mm-hmm. Actually, that
that step completely successful.
Mhm. That sounds very similar to a context manager I've seen in production, which did that and also timed the amount of time it took for that block of code to run as part of a performance measurement suite.
Another big advantage to context manager is using the with keyword. It's pretty prevalent to kill whenever
Mhm.
it's
Exactly.
whereas if you embed it generated.
Exactly. So you can see that these features have a little bit of overlap in terms of what you can accomplish with them, but there may be more fluent or clearer ways to write the code using one of the features or the other. But I like that question. It's a very good one because it gets really into the deep of why might you choose to do, because essentially you're doing the same, you have the same semantics, but the question is why would you express that in this way or that way? Can we go 1, 2, 3?
Have you ever seen context managers used with C code or with Python for resource management? Like
Yes.
create an object and explicitly read that object,
I think that
or non-explicitly create.
I think that there are context managers supplied by, I don't remember the name of the tool, but there was a tool that allowed you to interface with non-Python code. And I believe it had context managers that allowed you to, within blocks, do things like that. Actually, let me think for a second. You could, no, in the context manager you can't,
As long as your C object is a close method, there's already a built-in context manager that will give you the close method to call.
what he means, what,
Okay, so say you've got this, a piece of internal C or C++ code, and you need to clean up some resource. And so if you can express that cleanup as a close method in Python,
Without using the C Python API to wrap it up.
you still have to use the C Python API to
What
wrap
about
it.
Python?
You can use Python too,
As long
but
as you have that method.
you still need to have something called close.
I think,
As long as you've got that, then the built-in context, the built-in library will give you a context method that will guarantee you.
I think the example is also, I think you're also asking something along the lines of, say you had some processing code and you wanted to allocate like a memory pool for it to use and have it clean up the memory pool afterwards. That might be a really good way to, actually that's a very interesting thing you could do. If you wanted to, if you had some sort of if you're running Python on some sort of strange hardware where you needed to be very careful about allocation, you could possibly write a context manager that intercepts new calls and allocates them from a memory pool. It would be fairly tricky to do. You could also write a context manager that set up like a, just very simply in code style.
Like, for example, Apache Portal running context manager.
Mhm.
Context manager could just be an APR pool.
Mhm.
Basically, yeah, you create within the context, you're allocating out of that pool.
Mhm.
As soon as you leave, you guarantee everything is gone.
Exactly. You could do that. You could have like an object that represents a memory pool and pass it to your functions, and that pool itself would, when it gets garbage collected, when it's asked to be garbage collected, it could forcibly free everything else. Yeah. 2 and 3.
So my question was, how does this compose with generators yield from inside of a with block?
I have an example of that. It's
Or if you're going to get to it.
the generator itself has its own stack frame, so it should compose with the generator perfectly. In that, if you had like a database connection and you yielded elements out of it, then you will have the partial, you should have the partial frames available that exist within that context manager working fine. Now, what would be a strange thing is if that context manager did something, you could think that that might not compose very nicely if within the same thread that context manager made global changes. Because then you could, in another routine, make those global changes and it might get confusing. Mm-hmm. And then 3? Mm-hmm. 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 No, I think what you're saying is that, so a context manager doesn't know what's happening in the block. It's not like Ruby where you have these blocks that you pass to a function, and the function has some ability to maybe manipulate or see that block of code. In Python, anything that's in that with statement block doesn't really exist in the scope of the context manager. So what you couldn't do is you couldn't easily write a context manager that manipulated variables in the block that it wraps.
But you can do the other way around.
Yes.
The block can access the expression of the context manager.
Exactly. Exactly. Mm-hmm. Mm-hmm. Right. 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 Although I think in a decorator it could be, you could get around that. Or you could use the inspect module. Mm-hmm. If you guys really want to see something cool, I gave a talk a couple weeks ago about import hooks. I had a piece of code. When you import it, the module that imports it affects what actually gets imported. So if you import it from a file named foo, it'll return a foo to you. If you import it from a file named bar, it'll return a bar to you. But the underlying module itself doesn't change. It'll look up. I had an import hook, which if you desired, you could, within a string, write Perl code, and it would execute that Perl code and replace the string with that. I had an import hook. I tried it. It was very difficult. I had an import hook that I tried to have it infect modules up, but I didn't have time to finish writing it. But if you really want to see something cool, I'll show you some really dodgy things you can do with import hooks and looking up stack frames in CPython. Or we can look at more context managers. I think context managers themselves are maybe more practical for actual use in actual code bases. And some of you may have been sent to this conference by your companies, and you have to go back and say, oh, here's something useful that I can show you that'll help our product. And I don't think the perversions that I have in this file for import hooks will be as immediately productive. OK, so this is one example of a context manager. Another one is, this one is not thread safe, but this was actually something that I ended up using pretty often, locales. So you want to print a number with the proper commas or periods, the proper currency symbol, the proper grouping for digits, and you need to use a locale. But locale is global. So there's a set locale and a get locale, and you get your locale and you set it something, and you set your locale and you do it something. So say you had some sort of web page and you wanted to write the view so that it didn't have to know what locale you were in, and you could set the locale at a higher level where maybe you're pulling out the user object, right? But you don't want to write your view code so it has to know anything about the locale. You don't want the view code to have to set it and unset it. You could, for example, execute that view within a context manager that sets the locale and then unsets it when you're done. And that's what this does. It's a context manager called locale context. You give it the locale you want. So in the first example, it's NUS, so English as spoken in the US. In the second, it's English as spoken in Great Britain. All the context manager does is, by the way, unfortunately, this isn't thread safe, I don't think, It saves the old locale. It sets it to whatever you gave it. So it'll set it to US English, Australian English, British English, Taiwanese Chinese, mainland Chinese, anything. It yields out the local context for you just in case you need it for something. And then when you're done, it'll reset it back. So you can see in these two examples, I didn't have to worry about setting and unsetting. I could just wrap all that setting, that setup and tear down, in one place. And then everything in here will just obey the context that was set, or will obey the locale that was set in the context above. I think this is a really good example for a practical use for something like this. Because then you could write, then you could potentially have, something that looked like, or for, right? And you could do something like that. See? And you can see that this lower, this is the meat of the code that you have, is only concerned with what you really care about, which is printing out 1,000 whatever. And that all of this handling of setting locale and unsetting locale is happening in a different layer that is nicely segmented, that you don't have to worry about. It is, but it's all over the place. And you could have rewritten the locale module so that it required you to have an implicit context set up, so that something like currency would refer to some implicit module scope variable. I've seen context managers that do that they alter a module scope variable. So pretty much alter a global. You're still not getting away with it. But you could do something like, if you really want to do this better, if you wanted to rewrite the locale module better, you could do as locale, and then you could have locale actually provide like the currency. So that's how you could have a very nice interface for dealing with multiple locales without having to have any global state, but also being able to wrap it or be able to produce these objects. By the way, all these notes are available on Dropbox at the link right here, the 3 links, 1, 2, and 3. Here's another one, very common one, which is, so databases. We talked about databases. Here's an example where you can write multiple levels of context managers, and you can string them together. So let me see, where's this final version of it? This is the final version of it, where I have a connection, then I create a cursor, then I create a table. So you can think that I could even use a context manager to create a temporary table in the database. And when I'm done with execution, it'll clean up the table. That's just another pattern of what we've already talked about many times, but I think it's a really cool thing you could do. And so basically, I open example DB, I create a cursor, I create a table with a name and a salary field, I insert a couple values into it, I select some stuff out of it, and then at this point in the code, the connection is closed nicely, the cursor is already closed nicely, the table has been removed. There is, in fact, a transaction context manager available that I think I use within one of these guys already. But you could say a transaction is a perfect example of a context manager, of the use of a context manager.
And in the transaction context manager, you can then detect if the wrapped block threw an exception or not.
Mm-hmm.
And automatically roll back the transaction.
Mm-hmm. Yes, you could. That would be very cool. And then here's a very common example. This is the most common example. If you're ever opening a file in Python, just do with open as f. It'll handle the closing of the file for you automatically. This is your most trivial example of a context manager and something that you should just use automatically in your code. So,
How does that at context manager decorator work?
which one?
Beginning you showed a context manager implemented as a generator, and then it was decorated with at context manager.
Oh, yes. So the in context lib, there is a decorator called context manager, I believe. And you do like that, right? This is just a simple and very common use of this is a very common way to write context managers. There's two ways to write them. You can write them like this, or you can write them as a class. I believe you just do. Right? That's it. That's it. And this is the standard way. In fact, if you look at the ones I wrote most of them in that fashion because I find it just to be terser, and I don't like to write too much code to accomplish that much. So this is how I wrote this. Yields once. Yes. If it yields twice, I'm not sure. We can find out. Let's find out what happens. Is the context level variable? It is, and it's really nice. You can see this one doesn't care. So if I had an exception in here somewhere, like if this didn't assert correctly, then it would fall over and the locale would never be reset.
That becomes the context. That becomes the width value.
Exactly. Let me think. Is there anything that we could do really dodgy with context managers? I wonder if I have any really bad examples of stuff that you can do. It's a little bit harder. As a feature, I feel they're slightly harder to abuse than generators, which are very easy to abuse, or decorators, which are even easier to abuse. But oh yes. Oh yes, you could monkey. Mm-hmm. Yeah, I mean, you could do that, and so, but the basic pattern is here, I think, just some setup and some teardown with some block scope variable, and that's it. I think there's a.
Exit method gets an exception info. So if the exit method sees an exception, then it can react.
It doesn't. So here's the. Here's an example of one, right? This is something really cool that I used in another file of this set. What you do is whenever you print. Here. So this is what the format looks like of a context manager implemented as a generator. So there's some setup here. Then you yield control to the width block. If you do that in a try catch, then you can, or in a try except finally, then you can catch that exception coming out and handle it. Exactly. So what this does, this is actually a really interesting thing that I had actual means to use. Namely, you have some code and it prints stuff to standard out. It prints stuff using just a print statement, right? And you want to capture that and just check it. And you want to capture it within the program itself. So what I did was I reassigned sys.standardout and sys.standarderror to what got passed in, which happened to be string IO. And then I reversed my assignment in the cleanup step. And in the control step, every time you try and print something out, instead of printing it out, they'll go to, in this example, the buffer. And this will swallow errors. Exactly. So here, this will capture any print statements to standard out or standard error that foo tries to do into buff.
And if you were doing a transaction context manager, you would need try, yield, accept, rollback, else, commit.
Exactly. And so an example, well, I think I'm going in a different direction than what you're going. But from the previous example, one really neat way to use that was in the disassembly module. You can disassemble your bytecode, and it'll tell you the bytecode for the function that you have. But it prints it out to the screen. It doesn't return it as a string, right? So I wanted to show you that, for example, a function actually has the call function bytecode. But I couldn't ever assert that without capturing the output. So I used my capture print context manager to capture the output from this, and then I had it in the buffer. This is one way I could capture that output. Pretty cool. This is one thing that I talked about the first time I gave this, which I think is a very useful thing for intermediate Python users, the this module. And it seems very obscure, and it seems kind of like you'd never use it. But what it does is, given any object, or given any callable object, it'll tell you what the bytecode behind that callable object is. So when you have a function, def foo, that doesn't return anything, or returns none, all that actually happens behind the scenes are that you load none and you return none. This should be the same thing then as there we go. So we can see that these two constructs, in terms of the actual execution that's happening in the interpreter, are identical. Now, if you really want to get deep into Python, or to really debug your code because you have no idea what's happening, this is actually very useful. You can see literally what steps are happening, and if there's some syntax feature that you're not sure how it works or what's going on, and you want to see how far you can take it. One thing that I do very common is I'll disassemble it. I'll see the bytecode, like load const and return val. I'll go into the Python source, which anyone can download, and there's one file, ceval.c. And I just search for load const. So behind the scenes, this is what happens. This is what's really happening in the interpreter when you load a constant. When you have a function that does anything. It loads a const, and then and if you know C, it's actually very nicely written code, return value. So this is literally what's happening in the interpreter itself. And this can be a great way to debug very strange issues where a function isn't quite doing what you expect it to do, or you're not sure about some syntax. It's also a way that you can really look into how to maximally abuse the language. For example, I was showing some people during the break. On the flight, I had no reference materials. I was bored because it didn't have the TVs in the back of the screen. It only had the projection TV. And they were showing Big Bang Theory, which I don't quite like. So I wanted to find something to do. And so I started kind of looking through the source, and I realized that of the comparison operators, there's one additional comparison operator. There's greater than, there's less than, there's is not, in, not in. There's also one called exception matching. And you can abuse this feature to implement basic pattern matching, to implement a switch case statement in Python. I'll show it to you. It's maybe a little bit beyond what we came here to talk about, but it's really awful. So you might enjoy it. I've been showing this to everyone who will listen since I, and you can see this folder is full of awful things you shouldn't ever do. So this is what you can do. Look at that. I'll rewrite the example so it's a little bit better. So let's say, because we might want to switch on a predicate like x is. And if you kind of cover up that left-hand column, the try, raise, accept nonsense, it kind of looks like Java, but even more flexible because you can switch on strings, right? So isn't this cool? Wouldn't you put this into your code base if you could? And all you have to do to get this to work is put those 3 lines somewhere in your code. What those 3 lines do, I'm not quite sure. But the real lesson is, how did I figure out how to do this without any access to any Python documentation, because I didn't download any of the files before I left, and there was no Wi-Fi on the plane, and I was bored. All I did was I looked into the Python C code to figure out what actually happens when you try, raise, accept. I saw the bytecode. I grepped for the bytecode, just the names of them, and in this case it was there was just a comparison, and a comparison using exception compare, and I just traced through the code to see what happened, and I noticed in one part of the code, all it does is it tries to see if the exception that was raised matches a subclass of anything in the accepts, and then I realized, well, I can override that check, and that's what I'm doing. I'm overriding the check to see if something is a subclass of something else, and only returning true if the predicate is correct. That's how I implemented this monstrosity. But the underlying message, that I think is a very valuable message to especially intermediate users, is Python is a very nicely constructed language. And one thing that makes it so nice is that there is a nice layering of complexity. You can start as a novice user and never have to look into any of this stuff. You can write useful, productive code knowing just the basics of for loops, variable assignment, the simple statements, print statements, while, lists, sticks, just the simple concepts. And you can write real, productive, useful code. And at a time when you need to write something slightly more robust, you can use one of these notable features like a decorator to add common functionality to many different functions. You can use a generator to allow you to process things in discriminated units without having to have all the data available at once to do some sort of stream processing. You can use a context manager in order to wrap code with a setup and a teardown. And when you get bored with that and you really want to figure out how things are, or you have a big code base and you can't figure out how things are working, you can start looking at the bytecode. And the bytecode itself is very easy. It's a very simply implemented stack-based virtual machine. And you can look at that, and if you can read a little bit of C, the C itself is written very simply, you can start to see how the interpreter itself works. I had a coworker whose goal it is to become an expert in Python. And this coworker, she comes from a C, C++ background. And I told her, if you start from one end, learning all the code as Python, as a language in itself, that'll get you somewhere. But the other huge advantage you have is you can start from the other end. And you can start reading how C Python interpreter works. And with those two pieces, you can become an expert, no question, in 6 months to 9 months. No question. Of course, you'd have to spend the amount of time and energy that I spend on these things on your studies, but you could really get there. But as an intermediate user, I would really encourage you to start pushing the boundaries of your knowledge, because I think you'd be surprised at how much you can understand and how far you can go. And you may not need to go as far as this, but you can really understand really explicitly what is happening when, for example, you do something very simple like what's actually happening behind the scenes when you do this. And you can do this, but you could also do right? So you can unpack a tuple object into two variables. This is simple stuff, right? How do you write your own object that can be unpacked? How do you write your own custom class that can interact with this feature naturally? You can read through the docs, and the docs will tell you one thing, but the docs can be a little bit verbose. But you can also disassemble an example of tuple unpacking, find the relevant tokens, trace a little bit to see what those tokens do, and then you can figure out how to do this yourself. And in the magic file, I have an example of how to do tuple and keyword unpacking on custom objects. So that's I think at the bottom. So here you have, and it's very simple. For a simple object, all you need to do is define iter, and that's all you have to do. And if you've defined iter, then you can unpack it. That's for an iterable. It's 2 or 3 pieces, actually. Keyword. There we go. Keyword unpackable. So that's for a keyword unpackable, and this is for an unpackable. You need iter and next. And then you can have just an arbitrary foo object can be unpacked and can be sent to, notice I can send this object using the star pattern to unpack it as it's sent to another argument. And with the keyword unpackable, you just need keys and get item. Now, you could implement the whole interface if you wanted, but if you read that source code, you can see all you strictly ever need is keys and get item, because in the code, it only ever calls keys and get item. I think that is really, really cool. I am so, I've just spoken to you guys for like 3 hours on Python. I'm going to eat lunch, and I'm going to get right back into this. I'll take like a 30-minute break, and I'm going to dive right back into this. I think that's that cool. What do you guys think? I really want to hear your feedback. Are you guys? Are your minds blown, or is this just kind of ho hum for you? Do you think this is useful information? So when you get back to your company and some guy asks you, for example, I have this problem, and you see some code that one of your coworkers wrote, and he cut and paste code all over the place, and you notice there are 10 functions, and they all have the same little bit at the top of it. you guys know what you're going to do? Okay, you right there in the green. What's going to happen? What are you going to do? Oh, you abstract it. And do you know what feature you use to abstract it, maybe? To take a bunch of code at the top of a bunch of same functions and maybe at the bottom of these functions and put them in one place? Beautiful. So how about if you see some interesting, you see a for loop, and that for loop seems to be maintaining a lot of state about what's going on in that iteration. And you think, boy, this is messy. There's only 2 lines here that I really care about, and the rest of it is just mucking around with the stuff that I'm pulling out and just transforming into something I want to use. What might you use in that case to simplify your code or to take some of that complexity, that necessary complexity, and put it away somewhere a little bit out of the way so it doesn't cloud up? How about somebody who hasn't spoken yet? I think actually everyone has spoken except for you in the green right here. A generator. That's a fantastic idea. And so what about if one of your coworkers says, I need to connect to a database and I need to run a few selects and some inserts, and I think I kind of care if it falls over halfway through because it'll pull down our whole app and we'll lose $1 million, but I don't really know how to do this reliably. How about somebody in this row right here? What tool might you use to improve that? The context manager. And then if somebody comes up to you and says, boy, you spent all your time programming. You're the biggest loser I've ever met. And you say, no, I know someone even worse. What might you tell them? Exactly. You might tell them about this talk I gave. And I hope you've enjoyed it. I think we're coming to the end of it. I hope you've enjoyed this. If you have any questions, I'll put my email up there. All of the files that I have been using, I have available on Dropbox. They are full tutorials written out, so if you didn't get anything from me speaking, you just read through them. I think they're actually pretty useful. I'd love any feedback you have. In fact, I'd even love to take your email addresses if you're interested in receiving any more of these files or any updates to these. So I hope you've enjoyed it. I've really enjoyed working with you guys. Your skill level is far more advanced than what I had anticipated, which is a fantastic thing. It's been a little bit difficult to calibrate to where you guys are, but it's always, always a pleasure to speak to as enthusiastic and energetic and knowledgeable audience. And an audience as willing to participate as all of y'all, because I think every single person in this room has spoken or given an opinion or participated in some way, and I think that's really, really amazing. So I hope you guys enjoy the rest of the conference. I'm enjoying it a lot so far. Actually, with the switch example, if you've been reading the Python dev mailing list, there was some guy who was asking, can we add a keyword so that when you have a set of exceptions, you can fall through to them? And I was thinking I would respond and say, that's a really great idea, because then you could actually have fall through between the case blocks. But that also might get me banned from the Python community for life, so I don't know. Yes, yield from. Does anyone know what that example does? It exists in itertools as a function to do the exact same thing. Has anyone figured out what none for x and g if yield from x and false? Does anyone know what that does? Nobody? Clueless? Let's see. Let's find out. So yield from is a new feature. One thing that we should, people ask a lot, Python 2 or Python 3. And everybody has their own opinion. And some people say, oh, the libraries aren't there yet. And some people say, people have opinions going in every direction. I personally think that the distance between not knowing Python and knowing Python is far wider than the distance between knowing Python 2 and Python 3. Similarly, I think that if you have a code base in Python 2 and you want to move it to Python 3, there's going to be some issues. However, I have in the past worked with code bases written in Python 2.4, and moving them to 2.5 illustrated some issues in the code we had written. To a large degree, I think some of the issues that you'll realize if you migrate from 2 to 3 will be that maybe the first time you didn't quite do it right, and that some bugs were fixed. So I would say that for you guys, aggressively learn as much as you can about Python 3. Also, it is the sole target for new development, meaning new features are going into Python 3 and not into Python 2 these days. Some. So Python 3 includes a couple of features that are not available in Python 2, some of which are very useful. One is raise from. Raise from allows you to have exceptions refer to, you can raise an exception within an except block and it'll refer to the exception that it saw. So you can see chained exceptions. It's really useful because you might not want to get rid of why you got into that exceptional state. Like if you want to translate an exception, you might also want to keep the traceback from the original exception that you saw. Another one is yield from, delegation to subgenerators. What yield from does is it will essentially add in a 4x in the subgenerator and yield all the elements there. The one really awful thing about the code that I showed you guys was that you notice that we didn't talk about coroutines, but in coroutines, that yield statement can actually return a value. Because it can return a value, if you look at the syntax that the Python interpreter will accept, you can put a yield statement within a generator expression. So you can do, and you shouldn't do it, but you can. But they're not your mom. You don't have to listen to them. You can do this. Why would you want to do this? And what's it going to do? It's just going to give you 1, 2, 3. You can do that, right? Very simple. It's stupid. You'd never do this. The yield x will return none as a value. So it'll never return the none at the beginning. And that just works. It's just a weird perversion of the syntax, right? But you can see this is the exact same thing as just doing right? Now, because this yield in Python 2 can never return a value, this works. In Python 3, the generator can now actually return a value. The yield from statement itself can return a value, which is the return value of the generator, not the yielded value from the generator. So what this actually does is it flattens a list. For x, let's do flatten equals lambda. So this will guarantee to just flatten your list, right? Oops. Yield from, why doesn't this work? Is this not Python enough? It doesn't like, what doesn't it like? That's interesting. Let me try, what was the example I used before? This thing doesn't have, it might have been, 3.3 is where you need it. There. We need to go a little bit further. So, yeah, it's still in beta, but come on, it's coming out real soon now. And you know what? I'm going to, for those of you laughing in the audience, I'm going to find out what companies you work for. I'm going to interview there. I'm going to get a job there. And I'm going to add this to your code base, and you're going to have to debug it. So you better watch out. I told you, this is the cutting edge. I want to give you guys a little bit of, there we go. There, flatten. Okay, so if I do flatten, oops. So, right? This should flatten my list. Now, this exists in itertools as chain. So, now you might wonder, how did I find this? I don't remember. Sometimes I just kind of black out after I play around with Python. I just wake up and I see some code there, and who knows where it came from. So anyway, but I thought that was really cool. And this is coming to you real soon whenever 3.3 is released. Cool stuff, huh? So let's mingle. Let's chat. I think it's lunchtime too. So
Okay, no more questions?
I don't want to keep you guys any further if you have no more questions.